Welcome to Global Semi Insights. I'm your host. We are currently in week 10 of 2026, and the industry has just entered what we call the Angstrom era. The headlines this week are dominated by one name, Feynman. For months, the rumors were swirling. Would NVIDIA stay with the 2 nanometer node, or would they take a bigger leap? Today, we have the answer. According to multiple supply chain reports and the latest teases from GTC 2026, NVIDIA's next-generation Feynman architecture is skipping the standard 2 nanometer node entirely. Instead, it is heading straight to TSMC's A16 process, a revolutionary 1.6 nanometer class node. But why such a risky move? The answer lies in the power wall. As AI chips consume more electricity, traditional power delivery from the top of the chip has become a massive bottleneck. TSMC's A16 introduces Super Power Rail, also known as backside power delivery. By moving the power grid to the back of the wafer, NVIDIA can free up the top layers exclusively for high-speed data signals. This results in a 10% performance boost and a staggering 20% reduction in power consumption. For a mega cluster of AI GPUs, this 20% isn't just a number. It's the difference between a functional data center and a thermal disaster. But here's the kicker. NVIDIA isn't just relying on TSMC. Reports suggest they are tapping Intel's 14A process for Feynman's I/O components and utilizing EMIB advanced packaging. This multi-foundry strategy is the new playbook for 2026. Moving from the logic leaders to the connectivity masters, Marvell Technology. Their Q4 fiscal 2026 earnings report is out, and it is a masterpiece of growth. Net revenue hit a record $2.22 billion for the quarter, bringing the full-year total to $8.2 billion, a 42% jump year over year. What is driving this? It's the death of general-purpose compute. The giants of the cloud, Google, Amazon, and Meta, are no longer just buying off-the-shelf components. They are shifting to custom ASICs, application-specific integrated circuits. Marvell is at the heart of this shift. Their data center revenue now accounts for over 74% of their total sales. When we look closer at the numbers, we see that the demand for high-speed optical interconnects and custom AI compute tiles is accelerating. Marvell's chairman and CEO, Matt Murphy, noted that the operating leverage in their business model is hitting record highs because of the AI build-out. We are moving into a phase where the software dictates the hardware design. If you aren't building custom silicon specifically for your large language models, you are leaving money on the table. This is why Marvell is currently a $120 billion powerhouse. Next, let's look at the heartbeat of the AI chip, high bandwidth memory, HBM. The battle for HBM4 dominance is officially in full swing. This week, Samsung Electronics made a massive move. They have officially started shipping HBM4 samples to NVIDIA for the upcoming Vera Rubin platform. For a long time, Samsung was seen as playing catch-up to SK Hynix. But in 2026, the tides are turning. Samsung is using its own 4 nanometer foundry process to manufacture the HBM-based logic die. This gives them a massive vertical integration advantage. On the other side, SK Hynix, the current market leader with 70% share, is moving its mass production plan for the M15X factory in Chungju forward by 4 months. They are sticking to a partnership with TSMC for their base die, but they are facing yield challenges as the complexity of HBM4 increases. What makes HBM4 different? It's the move to an 11.7 gigabit per second bandwidth per pin and the transition to a 2048-bit interface. We are no longer just stacking memory. We are merging memory and logic into a single 3D stack. For investors and industry pros, the winner of the HBM4 cycle will likely control the AI hardware market for the next 3 years. Right now, it's a photo finish. Now, let's talk about the comeback story of the decade, Intel. At Mobile World Congress 2026, Intel finally showed the world that 18A is real and it is ready. They officially unveiled the Xeon 6 Plus, codenamed Clearwater Forest. This is a monster of a chip, packing up to 288 energy-efficient Darkmont cores. It's the first high-volume data center CPU built on the Intel 18A node. 18A is Intel's 1.8 nanometer class process, and it features 2 critical technologies: RibbonFET, Intel's gate-all-around architecture, and PowerVia, their version of backside power. For Intel, 18A is more than just a process node. It's a foundry resume. By delivering Clearwater Forest on time, Intel is proving to potential customers like NVIDIA, Microsoft, and Qualcomm that they can handle leading-edge production in their Arizona fabs. But it's not just about CPU cores. The Xeon 6 Plus uses Foveros Direct 3D packaging to stack 12 compute tiles on top of active base tiles. This is extreme heterogeneous integration. Intel is no longer just a PC chip company. They are positioning themselves as the only Western foundry capable of competing with TSMC at the sub-2 nanometer level. The next 12 months will determine if they can sustain the yields needed for a true market takeover. As we wrap up our Week 10 analysis, what does the rest of 2026 look like? The global semiconductor market is racing toward a $1 trillion valuation, but the growth is shifting from the cloud to the edge. We are seeing the emergence of domain-specific AI chips for everything from autonomous humanoid robots to smart infrastructure. Technologies like silicon photonics are finally moving from the lab to the rack, replacing traditional copper wiring with light-speed optical interconnects. This is the only way to solve the latency issues in 2026 scale AI clusters. Furthermore, the regionalization of the supply chain is reaching a tipping point. With new high-volume fabs ramping up in Germany, Japan, and the United States, the single point of failure risk that haunted the industry in 2021 is finally being mitigated. Thank you for joining me for this deep dive into the world of semiconductors. The pace of change is breathtaking, but we are here to make sure you stay ahead of every curve. Before you go, please take a second to like this video and save it for your reference. If you found this analysis helpful, subscribe to Global Semi Insights and share this video with your colleagues and professional network. Your engagement is what allows us to continue providing this level of detailed industry intelligence. I'm Global Semi Insights, and I will see you in the next deep dive. Stay curious and stay informed.